So here today we've got a Gallien Krueger 700 RB2. This amp is in a combo, but it originally had two of the woofers. One of them had gone out. The customer had replaced it and then brought it to me because there was no sound out of the woofers, only the tweeter would work. So first thing I did was get access to the speaker, and the main wires coming in, of course, were off the back of the speaker, so that's why they weren't working. Put that all back together, but as soon as I powered it up, a very loud sort of boom with a pop that would come through the amp, and you could actually watch the drivers push out pretty forcefully. So I'm guessing that's probably why that one low driver ended up blowing. So it's probably not good for the new one, probably not good for the old one. I got looking around on some of the boards, and there was actually information. This isn't something I had to diagnose myself, luckily, because it would have taken quite a bit of time probably. But there's two transistors in here. This is your main power amp board, and there's two transistors in here. And I'll put the numbers up on the screen there. But there's an SC3502 and an 2SA 1380, yeah. And they're these little guys. And apparently that was a very common problem with these, that those would actually be able to cause the pop. So I am replacing them with MJE 340 and MJE 350. That's the complementary pair. So you have to strip this whole board, this power amp board apart, which is going to take most of the time to do because you have this big heat sink that's fashioned on there with a fan, and there's 3 screws holding that and the whole board down. But then once you get onto the back, I'll try and show it here. But then once you get onto the back, there's screws in all of these slots, and there's screws that fasten the transistors all to the heatsink. You have to take every single one of those screws out to get access to this board. But once you do that, you'll see over on the front of the amp is right here. Over on the left-hand side here, it's Q11 and Q14 are going to be the ones that you'll need to replace. So that's what I'm in the process of doing. Q11 will be the MJE 340, and Q14 will be the 350. And of course, as we saw, the 340 is the one that I messed up when I put it in and ended up cracking it. Because these transistors are sort of up off the board and they fashion to the heatsink, really the proper way to do this would be to clean those holes out, put the transistor in, sort of get it aligned, put your heatsink back on, and then solder those in. I didn't do that, and consequently ended up breaking one, and I know better, but I was sort of in a rush, and yeah, that's what you get. So I wanted to show you how to remove a transistor, the easiest way that I found, because I struggled with this for years, and sometimes I'd burn up traces on boards and destroy stuff getting these little 3-pin transistors out. So the easiest way to do this is actually to put a bunch of extra fresh leaded solder, glob it up all across at least 2, but 3 of the pins would be good. Just like this. So you get it like that. So that then, and it's good to have a tool or something to grab a hold of this with. But then when you put your heat across, even if you can only reach a couple pins, it'll actually hit all three. And I do it on whatever, if it's on a slope, I do it on whatever the highest ones are. And it should pop right out like that. Quick and easy, and you don't have to overheat stuff. And then you can clean up your holes there, and you're good to go. Okay, so as you'll notice, I have a few screws in here to align all this. I put one of the main screws in the heatsink that goes into one of the other transistors, and then I put the two with the plastic bushings in there. And I snugged all of them down so it's all aligned. I looked from the top here to make sure that there's no gap in that transistor and it's all aligned and nothing's touching where it's not supposed to. So now I could solder that in there, and I know that it'll be aligned and have the correct spacing. So we'll do that now. And then if I need to, just because I've only got a couple screws in there, I can always pop it apart and check everything before I put it all back together. But yeah, that's about the easiest way to do it. And the correct way. Because otherwise your alignment can be off and you'll do like I did and crack the casing. Don't be in a rush. And you also want to make sure with these that when you solder them, you leave it on there long enough that you get solder on both sides, because they are, at the very least, double layer boards. Okay, so it's all back together. I've got the heatsink and the fan all attached. Board back in. Everything except the last couple screws, just in case I have to take it apart. And we're going to do the first power on. I'm plugged into my current limiter. Sometimes with these amps you have to sort of be aware that depending on what bulb you've got in your current limiter, if that's the type that you're using, that these can draw more power than what that can supply. So the bulb may come on, but it doesn't mean that there's a short. The only reason I do that, the first power up, even though it may not get enough power, is just in case there were a short in one of these transistors, before it can completely go and ruin the board or a bunch of other stuff. I can probably get it shut off in time. So yeah, so very important with these amps. If you're going to do this, I highly recommend going through the bias procedure, which that pot there, R28, you want to turn that fully counterclockwise. I don't have any speaker or anything hooked up to it. You shouldn't have to for these solid state amps. So first off, I will power it on, and then I'll take my multimeter, assuming that everything goes okay. There's no pops or fire. I'm going to measure back here at what is it, the J5 connector. There's 2 pins. We're just going to measure for DC voltage, and on the schematics it says 10 millivolts DC is what we want to aim for. So we'll get this powered on and biased up, and hopefully no fireworks. So we'll switch this on. And here we go. All right, so far so good. So we're only at 2 millivolts, so we'll bring that up some. Would be nice if I had a little plug or something to fit on there, but I don't. I don't think it's worth taking the time to make one. We're up to 4. Probably go a little bit more this time. 23, way too much. 10 right there, right on the money. Perfect. Okay, so we're ready to power this thing up. It's hooked up to the cabinet, and we're going to see if we have any more pops or whooshes or anything else going on. So I'll hold the mic down there to one of the speakers, and you'll hear what I hear. So just a little tiny pop, and then we'll switch it off. Just a little click, and that's it. So there's your issue. I think it was Q11 and Q14. You swap those out with the parts that I showed there on the screen, and that should solve your issue.